Good morning, friends. Now we will discuss our next instrumentation parameter or characteristics as a dead zone. So, what is dead zone? We will try to understand. It's a very interesting parameter in the instrumentation. So, first we will see its bookish definition. So, it is defined as the largest change of input quantity for which there is no output of the instruments. Means I am giving the input but I am not seeing any output from my instrument. This is the dead zone. So we'll go forward. So dead zone or dead band is a band of input values in where the output is 0, the output is dead, it means no action occurs or no output is there. Means I am giving some input but I am not getting output for that particular input, and then automatically my instrument start measuring the parameter. Now we will see it by the example of a temperature element, and now today I selected that is a pyrometer, because you already seen the basic temperature sensors RTD, then the thermocouple, and now seen the pyrometer. Pyrometer is the non-contact type of temperature sensor. Here, what is the example? Here the range is the 400 to 100 degrees Celsius, right? And what is saying dead zone is a 0.125% of span. Now see, this is a review also. Range is given, then how you calculate span? So now we are calculating span here as 1000 degrees Celsius minus 400 is coming to the 600 degrees Celsius. Now what is given in this example? The dead zone is the 0.125% of span. So 0.125 divided by 100 into 600 coming to the 0.75 degrees Celsius. Means unless until there is a 0.75 degrees Celsius things happen, it will not sense. After that it will start sensing. So dead zone of this particular sensor is a 0.75 degrees Celsius. Now we will understand more about the dead zone. Now we will understand with this graph. Here we are seeing the x-axis is the time and y-axis is the measured parameter. Here when I am giving the input, this is the input I am giving, and this is the dead time, no output is coming, and then after certain input we start getting the outputs. So in between this thing is the dead zone of that particular instrument, and this is the dead time. Now we will see it like this. Here we see like this. This is the kind of zone. It is the kind of zone. This time this one is going to the loading and this is the downloading. So we have seen it. What is the meaning of dead zone? Means unless there's a certain time when we are giving input, it is not getting the output. It may be due to the mechanical things in that, or it is due to the electronic things, or it is due to the process also. We will see one example of the process here in this picture. What we are seeing here? We are seeing here one electromagnetic flow meter. This is the remote type, means junction box is here and by the cable it may be connected by some converter. Here readings are coming. Now you see important things is the installation. It is like inverted U they made to make it full every time. But here they did a mistake. What mistake he did? water is coming from up, it is filling this filter, and then water is coming from here to here. Now the problem is the dead zone or dead band, because you know electromatic flow meter is the velocity meter. Here it is getting very less velocity due to this filter, and water is coming here, falling down here. It's coming, it is from here. Say okay, it may be the 5 meter, no problem. Okay, but every time when they are running this system, the reading in this converter is always 0. It is not a problem of flow meter. It is the instrument characteristics. When you are installing pressure transmitter, it's a level transmitter, it is a flow transmitter, or any transmitter instruments, you have to understand that what is the minimum values required that instrument start displaying to that input. That is the dead zone of this electromatic flow meter. If velocity is too less, it will always show you 0. When velocity is more than certain meter per second, then it start working. It will be 0.2 also, sometimes it's 0.3 also. But here it's the less than 0.1, so it is not working. When we make this filter to the height and we are giving the head so that it is getting the proper velocity, it start working. So by the example, we try to understand the dead band here. Thank you very much.